Welcome, welcome. Week 2, June 29th to July 5th. Happy 4th of July if you are watching it on that day. New KNEW 5 review piece, exponents part 2, guided. You are watching the video tutorial for the second piece of the exponent review of Algebra 1. So we're going to get started. Same directions. We are simplifying. No negative exponents allowed. We are going to go over exponents, negative exponents in our live. If we have already done that, you know what I'm talking about. We are going to bounce off of what we went over in our first video tutorial in number 4. So jump back there if you need a refresher on this. We are going to be looking at more division. So we are going to start with the divisor. That fraction bar acts as a divider of the numerator and the denominator, the top and the bottom of this fraction. The coefficients, the numbers, are going to kind of stay put for now before we simplify them. We have a negative on the top, we have a negative on the bottom. A negative on the top and a negative on the bottom are going to end up simplifying to be a positive because a negative divided by a negative becomes a positive. Okay? A 7 on the top and a 21 on the bottom is going to end up simplifying. And we know that because, again, a lot of what we did in Math 10, basic math, if you remember back to that course, worked with multiples, factors. So we can look at that in a minute, but what we really care about, the review really that we're talking about here, comes from these x's and these exponents. So on top, we have 7 x's. And on the bottom, we have 9 x's. And when we knock out the ones that, quote, cancel out, okay, or divide into 1, how many are we going to have left? Where are they going to be? We're going to have 2 left, and they are going to be on the bottom. So what we just talked about, the negative divided by the negative become the positive. We have a 7 on the top, we have a 21 on the bottom, we have x squared, and that ends up on the bottom. And now we have to see what happens with those numbers. Simply speaking, if you think in terms of factors or multiples, the 7 doesn't break down, but the 21 does. The 21 breaks down into 7 times 3. And then we can use the same rule. 7 on the top and 7 on the bottom, they divide to 1. And what do I have left? Well, everything that I do have left happens to be on the bottom. A 3, an x squared. And because everything ends up on the bottom, I do need a placeholder, and the placeholder that I have is a 1, and that goes on the top. So my answer is 1 over 3x squared, and I'm done. The other way I can look at it is 7 over 21 simplifies to 1/3, which still gives me the same answer, 1/3, and the x squared is still on the bottom. All right, let's look at the second one, number 2. We have that divider. I have a positive on the top, I have a negative on the bottom. Remember, I like to separate everything. So first, I'm simply looking at my signs. Positive on the top, negative on the bottom. Then I'm looking at my coefficients. I have a 15 on the top. I have a 3 on the bottom. And then I'm looking at x's. I have 11 x's on the top. I have 4 on the bottom. And again, this is where if you're getting good and you're seeing that pattern every time, you can say, how many do I have left and where are they, right? If I have 11 on the top, I have 4 on the bottom, I know I'm going to have 7 left and they're going to be on the top, right? So I start knocking them out. I can knock 4 of them out because I have common 4 in common, or 4 that get knocked out, and I'm going to have 7 of them left, and they're going to be on the top. And now I have to do my work. Okay, I have a positive on the top, negative on the bottom. That's going to leave me with a negative. Now, we've talked about this before, but it's worth mentioning again. When I just have one negative, it can go on the top, it can go on the bottom, it can go out in front, but it can only go one of those places, because as soon as I add in another one of those negatives to make it 2 negatives, like in number 1, it turns to a positive. So I'm just going to put it out in front. Okay, I'm going to float it because it's like the Queen of England. Okay, there's etiquette with the Queen of England. There's etiquette with the throne. Etiquette in math says that we don't like our negative in the denominator of a fraction. Now, is this something that I would take off points for? No. However, is it something where in a multiple choice question you're going to see it as an answer choice? Probably not. More than likely you're going to see an answer choice. The answer choice will have the negative popped out in front of the fraction bar. So it's just something you want to get used to, more so. So I'm going to pop it out to the front. Now I have to worry about my numbers. If I have a 15 and a 3, I can break my 15 into 5 times 3. And again, this is where I want to get comfortable with my factors, right? So 5 times 3, 5 and 3 are factors of 15. 3, oh, I'm sorry, I keep hitting that. There we go. So 5 and 3 are factors of 15. I have a 3 on the bottom, and then I had x to the 7, or 7x's on top from my previous step. So the 3's cancel out or divide to 1, okay, depending on what language you're using. What do I have left? I have a negative. On the top, I have 5x to the 7th. On the bottom, I have nothing. I can put a 1 as a placeholder for my final answer, or I can just have negative 5x to the 7th. That works too. And I'm done. Oh, my screen's frozen. All right. Let's look at number 3. All right, divider, my fraction bar. I have 23. I have 46. I have 8 B's on the top. I have 9 B's on the bottom. So right away I'm saying, how many B's do I have left? Where are they? I know I'm going to have 1 B left, and it's going to be on the bottom. And 23 and 46, those are kind of, they're larger numbers. They're not common numbers, but if I think about 23, if I double that, I get 46. So when I'm thinking about factors, you always want to think, well, if I double something, if I cut something in half, because those are going to be your most common ways to make another number. So 46, if I cut that in half, I get that 23. So on the bottom, I'm going to do 23 times 2. And on the top, I'm just going to leave 23 alone. So now my 23s are what divide to 1 or knock out. And what do I have left? Well, I put my dividing line there. And I always put it there because that helps me see if I have nothing on top or I have nothing on the bottom. Remember, I need something there. So if I don't have something there, that's when I put a 1. That's when I put that placeholder. So putting that division line there to start with, that's almost like last week when I put the slope line and I put the subtraction line there, or in the point slope formula, I put the subtraction line to start. It's setting yourself up for success because that's there to start. You have less of an opportunity to make a mistake if you know that it's there to begin with. It's reminding yourself that there's a high probability that there could be a 1 in this problem if you do not have a number above or below that line. Okay? So here, when those 23s knock out, you have nothing above that fraction line or that fraction bar. So you need a 1 on top of it, and then below it you have a 2b. So there you have it, 1 over 2b. All right, number 4. This looks a little bit different than the ones we've been doing. There's a couple letters there. There's not a double coefficient. You only have a coefficient on the bottom. So let's do it. All right, I put my division line there. Now I'm going to try to color code this for you. I'll try to pick purple too. Okay. Sorry, it takes me a minute to pick my colors. All right. So I have 3 A's on top, and then I have 2 B's on top. On the bottom, I have a 5, then I have an A, then I have 6 B's. Okay? So remember, numbers can only go with numbers, meaning coefficients, like a 5, a 3, a 7, an 8. Okay? So I have nothing to pair with that 5. I have to just leave that alone. Now, what can cancel with the A's? Well, A's can only cancel with A's. A's can only divide with other A's. So an A can only knock out with an A, and I can only knock out 1 because there's only 1 on the bottom. So I can only knock 1A with 1A. And B's, there's only 2 B's on top, so at most I can only knock out 2 B's. So I'm knocking out 1 B there and 1 B there. All right, so I'm going to, again, here's where I set myself up for success. I'm drawing a fraction bar here, and I'm writing what I have left. The only thing I have left on top are these 2 A's. Okay, so I have A and A, which gets me A squared. And then on bottom, I have a 5. And then I have 4 b's. So I have b to the 4th. So my final answer is a squared over 5b to the 4th. All right, let's look at number 5. Drawing my fraction line, or my fraction bar. I have negative 3, y, y. No, I'm not asking you something 5 times. I have 5 y's. On the bottom, I have 12. Then I have 6 x's. 1, 2, 3, 4, 5, 6. And then I have 8 y's. 1, 2, 3, 4, 5, 6, 7, 8. So even just looking at the color codedness of it, you can tell with the coefficients, as long as it simplifies, you can do something with it. The a's and the x's you can't do anything with, but the y's you can. So I'm going to see if I can, knock anything out there, how many I can. Okay, so I'm going to knock that out. 2, 3, 4, 5, and now I've run out of y's on top. So how many do I have left and where are they? I have 3 y's on the bottom. Okay. And then the coefficients in the front. Okay, well, what can I do with that? The 12, how can I rewrite that? Can I rewrite that with a 3 in it? Well, I can rewrite 12 as 3 times 4. So if I rewrite 12 as 3 times 4, then I can knock out a 3 with a 3. Now I don't have a coefficient up top, but I do still have that negative. So now I rewrite my fraction bar. And what do I have? All right, maybe I'll use the highlighter. All right, I have a negative. All right, so I have a negative. I have a squared. I have a 4. I have a mess of x's. And then I have y to the 3rd. Okay, so let's write this out. I have a negative a squared, 4 on the bottom, x to the 1, 2, 3, 4, 5, 6, y to the 3rd. And that's my answer. All right, now there's something very important in number 6 that we have to kind of draw attention to before we start this problem. Anything to the 0th power, okay, so say x to the 0th power is equal to 1. Say 3 to the 0th power is equal to 1. We could say 321 to the 0th power is still equal to 1. B to the 0th power is equal to 1. Okay, anything to the 0 power is equal to 1. So really, if we look at number 6, this x to the 0 that's in there, we can cross out, and 8 to the 0 we can also cross out, because they're not going to change the value of our problem, because that piece is equal to 1, and 1 does not change the value of our problem. So it's almost as if it disappears from our problem. So if I rewrote this problem, it would be 4y to the second over y to the fifth, z to the third. Now, you don't have to rewrite the problem, but if you want to make it look a little bit cleaner, you can. Now, rewriting this problem with a little bit of color coding, I have 4 and then 2 y's, or yy, and then on the bottom I have 5 y's, and then 3 z's. Try to make my z's not look like 2's. Crossing out what matches, which the only thing that matches here are my y's. Right now I have no more y's on top. How many do I have left? Where are they? There's 3 on the bottom. All right, this is getting a little messy. It's going down into my number 8, but all right, the only thing I have left on the top is a 4. What do I have left on the bottom? Well, I have y to the third, or 3 y's on the bottom, so I have y to the third. And then I also have 3 z's on the bottom, so I have z to the third on the bottom. So my final answer to this is 4 over y to the third, z to the third. All right, let's look at number 7. Drawing out my fraction bar. Color coding. I have 5, B, B, C. And then on the bottom, I have 10, B, B, C, C, C. Forgetting about our coefficients for a second, because I'll look if they have any nice factors that will allow me to cancel out what I can there. But just looking at our variables, both of my b's cancel out. So it leaves me with no b's whatsoever. And my 1c from the top cancels out with one of my c's from the bottom. So that leaves me with 2 c's, both on the bottom. And then again, looking at my coefficients, my 5 and my 10, I can rewrite the 10 on the bottom as 5 times 2. And then the 5's knock each other out. And that leaves me with a 2 on the bottom. So the only thing I have left, or the only things I have left, I have a 2 on the bottom, I have 2 c's on the bottom. And again, this is where that bar, that fraction line, is very, very helpful. Because if you look, I have nothing on the top. Everything's gone. Everything has been knocked out, wiped out. But I can't not have anything on the top, because if I wrote the bottom stuff as the top, well, it's not the top. It was on the bottom. So the 2 and the c squared is still on the bottom. It was on the bottom. It has to stay on the bottom. And in order to show that it's on the bottom, I have to write a 1 on the top as a placeholder. All right, number 8 is a 2-stepper. So if you look, The fraction bar not only acts as division, but it also acts as a grouping symbol in and of itself. So it's saying, in terms of order of operations, I'm going to keep the bottom from you so that you have to do the top. You have to do whatever is on the top before you come to the bottom. Okay? So if there is addition, if there's subtraction, if there's multiplication, if there's even division up top, you have to do that all before you do the fraction bar, before you do the division to get to the bottom. So you actually have to do this top piece here before you even look at the bottom. So doing that, okay, we have to go back to what we did in number 4. And we have to say, well, what did we learn last time? Well, 8 times -3 gives me -24. If I have 2 x's, and then I have 3 more x's, and then I have a y, and then I have 2 more y's, what am I going to have? What's my final answer on top going to be? Well, it's going to be -24, x to the 5th, y to the 3rd, and then that is going to be over -6, x to the 4th, y to the 3rd. So I have to do the top before I can do the division. Okay? Now, this, yes, we can write it out just like we've done every time, but you can also use logic and common sense and all what we've been doing all along without really writing it out longhand. Let's just look at what we've been doing without really writing it out. We have this negative divided by a negative. That's going to give me a positive. Okay. We have 24 divided by 6. That's going to give me a 4. And because the bigger number's on top, it's going to give us a 4/1 on top, right? If the 24 was on bottom, the 4 would go on the bottom. We have 5 x's on top and 4 x's on bottom. So when we cross them out, how many are we going to have left and where is it going to be? Well, we're going to have 1 left and it's going to be on the, you guessed it, on the top. Okay, I can put the 1 there. I don't have to. And you have y to the 3rd on top, y to the 3rd on the bottom. So you have 3 y's on the top, you have 3 y's on the bottom. So how many are you going to have left? Where are they going to be? Well, they're all going to cancel out, right? That 1 knocks out, 2 knocks out, 3 knocks out. Are there any y's left? No. So are you going to have any left? No, you're not. So our answer is simply positive 4/1x, or 4x, right? Positive 4/1x, or just 4x. And there you have it.